Hi, Assalamualaikum. Welcome back to speed revision session. Okay, today we continue to discuss chapter 1, measurements. So I will focus more on scientific investigation. Okay. Chapter 1, pengukuran, memandangkan peperiksaan SPM untuk ujian amali semakin dekat. So we will discuss more on that section, scientific investigation. Okay, for speed revision, you can look at the notes for chapter 1 measurement. Okay, base quantities and derived quantities. So under the first part, you have discussed about the difference between base quantities and derived quantities. Before that, let's look at base quantity, the definition for base quantity. Okay. So you can see this is a definition. Base quantity is a physical quantity which cannot be derived from another physical quantity. Okay. When we mention about physical quantity, this one you have studied in lower form. Asas, physical quantity, quantity that can be measured. Okay, you must be able to list all the base quantities that you have studied. How many that we have here? Okay, the first one we have length. You can see the symbol L and the unit. This is the unit. Okay, meter. Okay, length, symbol L, unit meter. And then we have mass, symbol M, unit kilogram. This is SI unit. SI unit. Standard International Unit. Okay. Then we have time, small t, and the unit is second. Then we have thermodynamic temperature, capital T. So unit is Kelvin. Or we also can call it absolute temperature. Okay, measured in Kelvin. Okay. And then electric current, symbol A, symbol I, unit ampere. SI unit, ampere. Luminous intensity, symbol I with subscript V, small v, IV. Unit is candela, small cd. Then we have one more, amount of substance, mole. This is the SI unit used. And then the symbol is small n. So how many that we have here? 1, 2, 3, 4, 5, 6, 7. There are 7 base quantities. You must be able to state a symbol and unit. Okay, that one is base quantity. Okay, how about the derived quantity? What is this derived quantity? Okay, a derived quantity can be described in terms of base quantity. Okay, through what? Multiplication division or both of the operation. Means kalau ada multiply and division, so there must be formula. So all the quantity that you determine by using formula combination of physical quantities, we call it derived quantity. Example, kinetic energy. Okay, you can see it is combined by multiplication and division of mass, length, time. So kinetic energy is example of derived quantity. Gravitational force, mass times length divided by time squared. So it's a combination of physical quantity. So it means kinetic energy and gravitational force are example of derived quantity. Okay. Next part, we discuss about scalar and vector. The difference between scalar quantity and vector quantity. Scalar quantity, physical quantity that have magnitude only. Example, mass. Okay, time taken. So direction is no need to mention direction, just mention the magnitude or the value only. Okay. Okay, other example is like time taken, okay, distance, speed. Okay. For vector quantity, physical quantity that have magnitude and direction. Example, force accelerates towards the sky. Force accelerate upwards. Velocity towards north. Okay, that one mention direction. So we call it vector quantity. Okay. Extra info below. Distance and speed are scalar quantities, while displacement and velocity are vector quantities. Okay, so you can see the difference between scalar and vector. Okay, now we go to the next part. 1.2 is interpretation of linear graph, which is very important when you carry out experiment and you complete the report experiment, you plot a graph based on the data recorded, and then you need to analyze the graph that you get. And then you must be able to state relationship between corresponding variable and manipulated variable. Okay. As an example here, let's say we have a straight line graph passes through the origin. Actually, for a straight line graph, the basic formula is y equals to mx plus c. So you all boleh apply maths untuk mudahkan kefahaman. Okay. So you have a straight line passes through the origin. Ini panggil described shape. Kalau ada soalan panggil you all describe shape ataupun terangkan bentuk graf yang diperolehi, describe shape, so this is the answer. A straight line that passes through the origin. Okay. So the relationship, ini kita panggil relationship. Okay, you plot a graph of y against x, so relationship is y and x. A straight line passes through the origin, so you write down y is directly proportional to x. Okay, the linear equation based on this formula, guna formula ni, y equals to mx plus c. So here, pass through origin, the c equals to 0. So we get y equals to mx. And then if you want to find m, m is known as gradient of the graph. Okay, so you can draw a triangle below the line. Size of triangle 4 times 4. Larger square means 8 cm times 8 cm. Okay. Okay, you can choose 2 points to calculate the gradient. Once you get the gradient, you substitute into this formula. So you will get the answer. Okay, for m. Okay, second straight line graph. You can see the graph is a straight line but intercept at y-axis. Intercept y-axis is C here. So a straight line that does not pass through origin, y-axis, intercept equals to C. So relationship, how to write relationship for this one? Y increases linearly with x. So linear equation, you can use y equals to mx plus c. So the value of c, you just read from here, intercept value what? Okay, and then the gradient, draw a triangle below the line, calculate the gradient. Thus you will get the equation for the straight line graph. I think you have studied this one in Form 3 Mathematics. You can apply that for this topic. Okay, the third one, which is a straight line graph, we have this type of graph. Okay, decreases. Okay, describe the shape. A straight line does not pass through origin. Y-intercept C, gradient is negative. So relationship y decreases linearly with x. Formula y equals to mx plus c. C is the y-intercept and then m is the gradient of the line. So we have y equals to mx plus c. So you must state the relationship correctly, based on the graph that you draw. Okay, if you draw your graph, you get this one, you write down increases linearly. If you get this one, negative gradient, decreases linearly. If pass through origin, directly proportional. Okay, don't write relationship as when x increase, y decrease, for example. Okay, this one cannot. Okay, you cannot use this one as relationship. Okay, so you kena guna perkataan yang tepat untuk relationship. Jangan guna hypothesis untuk tulis relationship. Okay, next. Okay. Sometimes when you carried out experiment, for example, experiment involving inertia using the hacksaw blade, okay, or the experiment of the simple pendulum, okay, when you plot a graph, sometimes you get a curved graph. So you also must be able to plot a graph which is curved and state the definition for the and state the relationship for the curved graph. Okay, for this one, gradient of the graph positive, either this way or this way. So for this bow's shape, you will get y increases with x. Relationship, how to write? Y increases with x. Okay. And this one, you get gradient negative So relationship y decreases with x. Okay, this one also curve. Okay, but you can see this point, it does not touching y-axis, and this one also not touching x-axis. Okay, it's just getting closer but never touch or intersect. So this one we call it inversely proportional to x. Okay, the way you write using the symbol is y directly proportional to 1 over x. Also can be stated as y directly proportional to 1 over x. Okay? So if you plot a graph y against x, you get this curve. If you plot a graph y against 1 over x, so you will get directly proportional. Okay? Okay, let's look at one example. This is from textbook. Experiment 1.1. This experiment is simple pendulum experiment. Period of oscillation of simple pendulum depends on its length. So this is how you write inference. RV depends on MV. So in this case, RV is period of oscillation, MV is length of pendulum. Hypothesis. The longer the length of simple pendulum, the longer period of oscillation. Aim to investigate relationship between length of simple pendulum L and period of oscillation of simple pendulum T. Okay, so you have this one in manipulated variable, length of pendulum, you can define symbol. Corresponding variable, period of oscillation, T. Constant variable, mass of pendulum bob. Apparatus, you have retort stand, protractor, stopwatch, Motero G clamp, material 100 cm thread and 2 small pieces of wood. Okay, so you can carry out experiment, displace the bob with at small angle less than 10, decrease, displace and release to oscillate. Okay, so using the stopwatch, you measure time taken for 20 complete oscillation. Repeat it twice until you get the first reading and the second reading. Okay, now let's look at the result. Okay, so you can see from the table here, for example, when you carry out experiment for this simple pendulum, make sure there is a level and unit. Okay, for the column, for each of the column, there must be level and unit. And then the time recorded according to the accuracy of the instrument used. In this case, you use the stopwatch that can measure the smallest value 0.1 second. So all the reading must be 0.1. For example, this one 25, you cannot write as 25 only. You must write 25.0. So that all stated at the same accuracy. Okay. T2 also same. And then calculate for average. Number of dp for the secondary data, you can start to record 2 to 4 dp. Okay. So you have T1 and T2, then calculate for average. Get this one. Period of oscillation is the time taken, which is average, divided by 20. So we get all the readings for period T. And then calculate for t squared. Just press on the button. So this one we call it secondary data. So 2 to 4 dp. Yeah? Okay, the state 2 to 4 dp. So when you plot a graph, you can round it off. Huh? Okay, let's try to plot a graph of t against L. Okay, T and L. Okay, so how to mark the scale? Okay, you look at the biggest value, 1.658. You always start the graph from 0. Start from the 0. Start from 0 here. Okay, the biggest one, 1.654. So let's say one box here, I put 0.2. Okay, and then for the x-axis, start from 20. Okay, this is the starting value is 20, but the biggest one is 70. I want to start from 0 also for x-axis. Start with 10. Okay, so this for this axis you need to label. This is T unit second. This is L unit. It's not L, sorry. M, nice. Yeah, correct. Correct. Yeah. Okay, length of pendulum, so label ada unit, ada okay, scale must be even and uniform, tak ada odd scale. Okay, now you can transfer the point. Okay, boleh transfer points. Okay, 0.88320. Okay, 20. Nearly here. Just cross the mark. 51.1. 1.25. So I round off 1.4. 1.5460. 70. Okay, now we want to draw a graph. Use freehand. If you cannot draw using a freehand, you can have a curve ruler that can be bent. Okay, that one also can. I'm using this drawing board. It's a bit slippery, so I cannot maintain really nice shape. But I try to use freehand to draw. Okay, something like this. So make sure you draw best fit line. Okay, if the line can pass through all the points, that one is the good graph or good data. If not, you need to balance above and below. Okay, so best fit line you must draw. Okay. Okay, next you want to draw t squared against L. You can start from 0. Look at t. Okay, value of t squared, the biggest one is 2.749. Let's say about 3. So I will choose 0.5 for 10 division. Okay, 0.5, 1.0, 1.5, 2.0, 2.5, 3.0. Okay, then same thing here, 10, 20, 30, 40, 50, 70. Okay, now we want to transfer points 20, 0.78. Okay, transfer the first point. Nearly here. And 1.228. And 1.56. The next 40, 1.56. Next 1.95. Okay, 50, 1.95. Okay, then 2.37, 60, we miss out 1.60, 70, 60, 70, and then 2.75. Okay, so for this one, you can draw straight line graph. Okay, use ruler to draw. Okay, we have this kind of graph, a straight line graph, and make sure best fit line. Okay, so the graph, make sure there's no thick line or any broken parts for the line. Okay, make sure it is a straight and sharp line and smooth also. Okay, so the point must, if can pass through all the point, that one is the best one. If like this, I just show you one example. Let's say when you carried out experiment, suddenly when you plot a graph, okay, you found that one of the point is very far from the, the line that you draw. So when the data here, use ruler and measure, the distance must be less or equals 0.5 cm. If more than 0.5 means this point may be wrong. Okay, so when you carried out experiment during the practical exam, for example, you don't clean up first. Don't clean up first. Okay, if you find that there's one point very far from the line, okay, so you can try or redo for this point. Try if you can, try to redo for this point. Maybe something wrong during the experiment, so you get the point very far from the line. Okay, so this is one suggestion for you all to do it. Other than that, okay, let's say you have points. It is close to the line. Okay, some of it close to the line, but not on the point. Ada juga bila buat eksperimen, sometimes ada banyak error. Okay, okay, nampak point ni dia tak ada atas garis. So if the points cannot be on the line, also can. But make sure the number of point which is not on the line, ini tak ada atas garis, not on the line, they are balanced above and below, and at least the difference between the point is 1. Okay, maksudnya perbezaan bilangan point atas dengan bawah untuk point yang tak ada atas garis ini, dia mestilah sama ataupun perbezaan 1 point sahaja. Okay, the difference in 1 point, like 2, 1. Okay, ini boleh. Okay, okay, 2, 2 boleh. Okay, 2, 0 tak boleh. Okay, so you must draw best fit line. Okay, because when you carry out experiment, sometimes the data not very nicely will be on the line. So what you do, you just draw best fit line. Okay, draw best fit line saja. Okay, best fit line. Garis penyesuaian terbaik. Okay, and then you also must be able to answer the question related to the graph. Okay, plot a graph. We have plotted the graph. Describe or state the shape. This one I mentioned already, how to describe or state. Okay. And then determine the gradient of the graph. Determine the gradient. The first step that you must do is draw triangle. Okay, on the graph below the line. If can, 4 times 4 like the square. And then show substitution. Gantian, tunjuk gantian nilai. Kalau boleh atas graf itu you tandakan point ataupun you tandakan, contohnya graf macam ni, pilih dua point yang you nak buat calculate gradient ataupun lukis triangle below the line. And then answer, final answer mesti ada unit. Ini cara yang betul untuk menentukan gradient atau kecerunan. The correct way to determine the gradient of the graph. Okay, jadi mesti ada 3 point ni. Draw triangle or you mark 2 point on the line. Ini adalah dalam graph, pada graph itu. Substitution, you show how you calculate. And then the final answer plus correct unit. Okay. And then state operational definition for period of oscillation. Apa tu beza? Definition and operational definition. If definition, you just can memorize from the books mentioned, so you can just calculate. When we talk about operational definition, means what you do during the experiment to determine the period of oscillation. Okay, operation, apa yang you buat. Okay, so you write down the process of calculating this period of oscillation. So period of oscillation, for me, we can say something like the formula that you use to calculate period is determined by T equals to time for 20 oscillation divided by 20. So this one we call it operational definition. Don't write time taken for one complete oscillation. That one is definition. So that's the difference between operational definition and definition. Conclusion is based on the graph that you get. Okay, let's say from the graph of T squared against L, so you get T squared directly proportional to L. That one is a relationship. So the conclusion, go back to the hypothesis. So from this experiment, we find that when length of pendulum increases, the period of oscillation increases. Okay, hypothesis accepted. Okay, there's a difference between conclusion. Sometimes they want you to state relationship, sometimes conclusion. Relationship yang saya mention tadi lah, directly proportional, increases linearly, increase with x, decrease with x, depends on the shape of the graph that you draw. So all these answers must based on your graph, not theory, based on your graph. Okay. So I think that's all for my section today. So I have discussed about speed revision on chapter 1, 1.1 and 1.2. And then you must go and try to understand more about how to write relationship, how to analyze graph. Okay, it's very important for you all to plot a graph correctly. Okay, so I think that's all my session today. Thank you for watching today. Bye.